This is section 1-4, pairs of angles. I'm going to go through the warm-up pretty quickly here. So in example, warm-up 1, there's a minus right here. This is really like a -1. We need to distribute that minus or that -1 to both terms in the parentheses. We end up with 90 minus x minus 20, and then combine like terms. The 90 and the minus 20 or -20 becomes 70, so 70 minus x or -x plus 70. Same thing in the next one, distribute, so we get 180 minus 3x plus 10 because of the two negatives there. Combine like terms, we get 190 plus 3x or 3x plus 190 in standard form. Number 3, form more than twice a number. So whenever we have more than, that means adding, so it can either be 4 plus 2n or 2n plus 4. And for less than, remember that we are going to have to switch this around for less than. So 6 less than half a number would be half a number minus 6. Okay, our new vocabulary, we have adjacent angles. Adjacent angles are basically right next to each other. It's defined as having a common vertex and a common side. So we've got angle 1 and angle 2. They have a common vertex and they're sharing a common ray here, a common side. Okay, so they have to be right next to each other. Angles 1 and 2 are adjacent angles. A linear pair is a pair of adjacent angles. So if something's adjacent, then it has to be, if something is linear, then it has to be adjacent. Sorry, I almost said that backwards. A linear pair of angles is a pair of adjacent angles whose non-common sides are opposite rays. And so they actually form a straight line. So here's my line, and then the angles are adjacent. So if they're on a line and they're adjacent, that's a linear pair. Notice that these two angles did not form a straight line. It's not 180 degrees here. In total, maybe they're like 80 degrees, but they're not 180. It'd have to be a straight line. So straight line, the word line is in linear. Line is linear pair, adjacent is right next to each other. Okay, let's identify some angle pairs. Tell whether the angles are only adjacent, adjacent and form a linear pair, or not adjacent. So the first angle, they give us angle AEB. AEB is this angle right here, and angle BED is the large angle. So I've marked angle AEB in red and angle BED in blue for you, and those are both adjacent because they're next to each other, and they form a linear pair because they form a line. Example B. Okay, the next one, angle AEB, I'll mark in red, and BEC, I'll mark in blue. Those do not form a straight line 180 degrees, but they are next to each other, so they're adjacent. Okay, and then example C. We've got angle DEC, I'll mark in red. DEC is this little one, because it goes D to E to C. And angle AEB, I'll mark in blue. Now these share a common vertex, but they do not share a common line. Okay, so, or a common side. So they're not adjacent, and they're also not a linear pair. They don't add up to 180. They're on this line, but they don't add up to 180. So this would be neither. Okay, our next two vocab words, we've got complementary angles. Those add up to 90. You've probably heard of these before. And supplementary angles add up to 180. Think super for supplementary. Super is the larger one, so it's 180. Okay, so find the measure of each of the following. To find the measure of the complement, you're always going to take, since it's a complement, it's 90 degrees. You do 90 minus what's given to you. So 90 minus 59, and we can calculate that, which would be 31 degrees. Okay, and then our next one, the supplement. So you do 180 for supplementary minus what's given to you, 7x plus 10. Now remember, we have to distribute the negative. So we'd get 180 minus 7x minus 10. Combine like terms, the 180 and the minus 10. So we end up with 170 minus 7x. Okay, in example 3, an angle is 10 more than 3 times the measure of its complement. Find the measure of the complement. Well, remember, a complement is always going to be 90 minus what we don't know, x. Okay, so an angle is 10 more than 3 times the measure of its complement. So we start with distributive property. X is 10 plus 270 minus 3x, combine like terms. So x equals 280 minus 3x. Minus 3x. And now I can add 3x to both sides. I could have done that first too, it doesn't matter. So I get 4x equals 280. Divide both sides by 4. And x is 70 degrees. And we can make sure that this makes sense. We can plug this back in. So the measure of the complement would have been 90 minus 70, which is 20 degrees. If x is 70, then the measure of its complement would be 20. That makes sense, since they're going to add up to 90 degrees. Okay, if the measure of angle 1 is 47, and it said that angle 1 is congruent to angle 2. So if angle 1 is 47 degrees, angle 2 is going to also be equal to 47 degrees. And angle 3 is the complement. It said angle 1 and angle 3 are complementary, right? So angle 3 would be equal to 90 minus 47 degrees, which gives us 43 degrees. And angle 4 is complementary to angle 2, which would really just be the same thing. So 90 minus 47 degrees, which is 43 degrees. Okay, this is really important. We're going to use vertical angles all year. So this next part here says, another angle pair relationship exists between two angles whose sides form two pairs of opposite rays. These are vertical angles. Okay, so it's really when we have an intersection and the angles opposite of each other are vertical. Vertical angles are congruent to each other, so that's really helpful to know. Angle 1 and angle 3 are vertical angles, and angle 2 and angle 4 are opposite angles. So identifying vertical angles here. HML, since it's opposite to JMK, those are vertical angles. So angle HML, so H to M to L, and angle JMK are vertical angles. If you want to name another pair of vertical angles, we could say angle HMJ, I'll mark this in red, HMJ, and angle LMK. And angle LMK are vertical angles.